Alright, in this video I wanted to just do a quick review of electron configurations and valence electrons, because that's going to be important to what we do with chemical bonding later on in the chapter. Alright, so let's start with writing electron configurations for neutral atoms and ions. Alright, so first we have nitrogen, and we want to write the electron configuration. So remember, we can use the periodic table where the periodic table is broken down into the S block, the P block, the D block, and the F block. And so what those blocks tell us is, when I look at the atomic numbers, that tells me which electron is going into which orbital. So the first row is the principal quantum number is 1, and then 2, and then 3. So effectively, right, helium for this exercise should kind of really be here, because the first two electrons are filling the 1s, and then the 2s, 2p, 3s, 3p, 4s, and then remember the d's are weird. While we're in the fourth row, these are actually the 3d's. So the principal quantum number for when we're filling the d electrons is 1 less than the row we're in. Then we're back up to the 4p's, 5s, 4d, 5p, 6s. Then we actually go to the f's. The f's are 2 less than they're in. So these are the 4f's. Then we're back to the 5d's, 6p, 7s, 5f, back to the 6d's, and then the 7p's. So we fill up the orbitals. We can put 2 in the s subshell, 6 in the p subshell, until we get to our element. So we're looking for nitrogen. So first we fill up the 1s's, and so we have 1s2. Then we're here, 2s2, and then I get here and I have 1, 2, 3. These are the 2p's, so then I have 2p3. And that would be the electron configuration for nitrogen. Okay, here we have bromine, but it's not a neutral bromine. It's a bromine with a negative charge. So remember, when we have negatively charged ions, that means they've added that many electrons. So bromine is here, but because it's Br minus, it's effectively going to have the same electron configuration as krypton. So when we want to write the electron configuration for Br minus, what we're essentially doing is writing the electron configuration for krypton. So I start with the 1s again, and then the 2s, then the 2p's, 3s, 3p's, 3p6, then 4s2, then we're down to the 3d's, so it's 3d10, and then I have 1, 2, 3, 4, 5, 6, so 4p6. So that would be electron configuration for Br minus. Okay, one last example for electron configurations. Here I have a nickel +2 cation, and so when we have positive charges, it's the opposite of negative charges, so we've lost 2 electrons. But the reason I wanted to do this example specifically is to remind you that when we have cations of the transition metals, even though we're putting in the 3d's last, when we form cations, we always take away the highest s electrons first. So the electron configuration for neutral nickel, right, so just Ni, not Ni+, would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then it would be 1, 2, 3, 4, 5, 6, 7, 8, and so it would be 3d8. With nickel +2, I've got to take away 2 electrons, and so even though I put the d's in last, it's the s's that get taken away first, and so it's +2, so I've got to lose 2 S's. There are only 2 4S's. And so then the electron configuration for nickel 2 plus would be and then we've lost the 2 4S's, and so then it would finish with 3D8. Right? If the positive charge had been any higher, then I'd start taking the D's away. So nickel plus 3 would be 1s2, 2s2, 2p6, 3s2, 3p6. I already took away the 2 S's, and so then it would end with 3d7 if nickel had a plus 3 charge. Okay, finally, just want to do some examples of counting the valence electrons. And so we'll do those on the next slide, where I've got a periodic table again. All right, and so remember for main group elements, so when I say main group, I'm talking about the S block and the P block. The number of valence electrons is just given by what column it's in, but we skip the D's and the F's that might be in between. So, for example, for nitrogen, let's make a little table here. So I'll write the valence and then the core. And so for nitrogen, it's in the 1, 2, skip the D's, 3, 4, 5. It's in the 5th column. So nitrogen has 5 valence electrons. And then all the electrons must either be valence or core. So nitrogen has a total of 7 electrons. So the total 7 minus the 5 valence leaves us with 2 core. When I look at phosphorus, phosphorus is in the same column as nitrogen. So it should have the same number of valence electrons. And in fact, right, when I go 1, 2, skip the D's, 3, 4, 5, phosphorus will also have 5 valence electrons. Now phosphorus has 15 total. So the 15 total minus the 5 valence leaves 10 core electrons. All right, cesium is down here. It's also main group. It's just in the S block. It's in the 1st column. So cesium has 1 valence electron. It has 55 total, so that means 54 of them must be core. Finally, one more example, we have iron, Fe. Iron is right here. When we're in the D block, it's just whatever column it's in. So iron is in 1, 2, 3, 4, 5, 6, 7, 8. So iron has 8 valence electrons. It has 26 total, so that leaves 26 minus 8 is 18. So it has 18 core electrons. Finally, we're looking at an ion. So Br minus, right? It's like a bromine, or it is a bromine, but it's added an electron, right? So it really looks like krypton. So when I count the valence electrons, 1, 2, 3, 4, 5, 6, 7. A neutral bromine would have 7 valence electrons, but because it's Br minus, it has 8 valence electrons. Right, and so it has a total of 36 electrons, because bromine has 35. Since it's negative, it has a total of 36. So 36 minus 8. I'm sorry, not 18, but 28. Let's fix that. 28, that looks better. All right, so this is our review of electron configurations and valence and core electrons.